Hello, this is Gabe Rueda and David Parr. We are the two members of our group, and I'm recording right now the items to our rocket that we're gonna set up with the construction process. The first step we're going to do is put these 3 wings onto the fin mount, which attach to the fins onto the bottom of the rocket. The next step is this is the completed fill mount, the black tube. We're going to put it into the back of the rocket and glue it in. Our next step is we're going to attach the 3 fins to the fill mount onto the body tube. Alright, not good.
The next step is to install the shock cord onto the rocket, which keeps the rocket tip from falling when the parachute deploys.
Okay.
We assembled the shock cord mount, and the next step is to install the nose cone. We assembled the nose cone, and the next step is to apply the decals to the rocket's body.
They're awesome decals! Hello, we just added some extra creativity to the project. We labeled our rocket. It's called a Parr 2150 rocket. And we put our initials at the bottom, GRDP, on all 3 fins. We just finished adding the decals to the rocket and the creativity, and we just attached the parachute to the rocket nose. Hello, we just inserted the rocket into the bottom of the rocket tube, and David is going to put the metal thing into the rocket, which helps it ignite. There you go. This is the final step of the construction process. We are done with the rocket, and we are about to go launch. This is the launch pad right there, and then this is the button that we're going to press to launch it. This is the protractor that we're going to use. It's a clear one, and we attached a thin ribbon to it, and our weight is a miniature weighted football. Hello, we're about to launch the rocket. We are currently at Gabe Rueda's house in the back, in the big field, and this is the rocket on its launch pad. It has a safety thing on the top. I'm standing at the point where David is gonna press the button, and he's gonna have the protractor, and he's gonna be taking an angle of elevation, raising his arm slowly to match the rocket up in the air, and that will get the angle of elevation for us. And the X and the triangle that it makes is 15 feet. Just for safety, if anything falls off, if anything launches on accident. And then here's a line leading towards the button that David is gonna press. And then here's the protractor that David's going to be holding, and I'll be videoing from a distance away. Alright. 2, 1. This is right after the launch. David is looking up into the sky where the rocket was, and it is right next almost to zero, and it's looking about 88 degrees. 88. So we're going to use that 88-degree angle of elevation in our calculations. Alright, these are the calculations for the height of our Parr 2150 rocket. This is a triangle that it made with the rocket launch and the angle of elevation. We found out the angle of elevation was 88 degrees. That was with David with the protractor aiming it up where the rocket was at its highest point. And since this is a 90-degree angle, since it's perpendicular to the ground where the rocket was, the other angle is 2 degrees. The 15 feet is the distance from where the button where he pressed it, where he was standing with the protractor, to the rocket where it was. Now, since we don't have the height, which is the Y, and we have the X, we need to use tangent. So we're going to use tan of 88 degrees equals Y over 15, because this is the X, which is 15 feet. Now we need to multiply this by 15 to get Y by itself, and then Y is going to equal tan of 88 degrees times 15. And in the calculator, we entered in, you close the parentheses, and you times it by 15, and that comes out to 429.544 feet. Since David is 5.5 feet tall, we have to add his height to the total height of the rocket. We have to add 5.5, and in the calculator we do that and add 5.5, and that comes out to 435.044. So we write it down, 435.044 feet.